So a compound is atoms that are joined together. They're not put together with superglue. Well, if you want to think of it that way, you can. They're held together by chemical bonds. And we'll talk more about chemical bonds later, but there are attractions between charged particles, and that the electrons and the protons in the atoms, the attractions between protons and electrons in adjacent atoms that cause the chemical bonds. And there's two basic types, ionic and covalent. So ionic bonds occur between metals and nonmetals. They involve the transfer of electrons from one atom to another. We talked about how atoms can form ions by gaining or losing electrons. So we also talked about metals form cations. So the metal loses electrons. Those electrons have to go somewhere. The nonmetal accepts the electrons, becomes an anion. They have a positive ion, a negative ion, and they are attracted to each other because their charges are opposite. Electrical charges are not the same as magnetic fields, but they behave similarly. And so we have more experience with magnets. You understand that a magnet will stick to the refrigerator, right? Or two Brio trains. If you get them lined up right, they stick together. If you switch one around, they repel each other. So essentially an ionic compound is like two magnets, and they're just zing, they attract to each other. So in the ionic compound, these are going to be crystalline solids. They're going to have a lattice, a regular three-dimensional array of alternating cations and anions. A little bit like magnetics, that toy with the little magnetic balls and sticks. And it's going to be continuous throughout the whole piece of matter, the whole compound. So here's an illustration of what's going on, looking at sodium chloride. So here's sodium. Sodium metal is soft enough you can cut it with a butter knife. If you throw it in a sink of water, it's going to explode, damaging property and probably killing you. Very explosive in contact with water. Here we've got a chlorine atom. Chlorine atoms form little molecules naturally. Chlorine gas at room temperature, and it's toxic. Sodium is a metal, chlorine is a nonmetal. What happens is that sodium will tend to lose an electron, becoming a sodium ion. That electron will be transferred to the chlorine atom. By gaining one electron, it becomes an anion. Now it has a negative charge, the sodium has a positive charge, and they are attracted to each other. Essentially, they stick together. And so we get this alternating pattern of positive, negative, throughout the salt crystal. And the result is the ionic compound sodium chloride, which we know as table salt, and we sprinkle on our food and eat regularly. And in small doses, it's actually necessary for life. So the compounds of table salt are very different from the compounds of the components of its individual elements. The other kind of bond is covalent. This prefix co means sharing, right? So covalent bond involves sharing of electrons. Covalent bonds occur between two or more nonmetals. What kind of ions do nonmetals want to form? Positive or negative? Negative. If both nonmetals want to form negative ions, who's going to give one up? Neither is willing to give up an electron and become positive. So because they can't agree on who's going to give one up, they're going to share the electrons instead. And we'll go into way more detail about covalent bonds later. But important to understand that covalent bonds are between nonmetals. If there's a metal involved, it's ionic. When we get these covalently bound atoms, they compose a molecule. And so we call compounds containing these molecules molecular compounds. So if it has a covalent bond, it forms a molecular compound. An ionic bond forms an ionic compound.